Hello everybody. I'm Michael. I'm coming from Belgium to present you something about magic. And I've been given, I think possibly the worst time slot on any conference. The time slot is just before lunch. Because everybody wants to go to lunch, they're hungry. This is in English called the graveyard session. Because people are literally dying to get some food. So I will try to make it as interactive and appealing as possible, that you don't run out after 10 minutes, okay, this is boring, I'm going to get some food. Well, I've been promised that the food will stay and not be presented now, so you can't run. When I first thought about this presentation, I thought, okay, we are running every time against the same issues. Issues that we are put under a lot of stress as testers. We have to test a lot. We have a lot of possibilities, we have a lot of combinations to test. How can you manage that? I've seen all kinds of initiatives. Outsourcing, automation, different techniques, developers that test, agile, pair testing, session-based testing, a lot of techniques. But unfortunately, just until right now, I haven't encountered one single one that can count it as the silver bullet that would solve all my problems as a tester. And thus came the topic of this presentation, how can you reduce your testing efforts magically? Well, that's not a good thing, but one of my first slides is to disappoint you. I am not a magician. I cannot do magic, I cannot do tricks, I have no cards up my sleeve, I don't have rabbits, I don't have one beautiful assistant that I can saw through, I have nothing of that. The only thing I have is my experience and my skills as a tester. That is my toolkit. That is where I will guide you through. A couple of months ago, I was working for the federal government of Belgium. And Belgium, that is a very strange country. What is so strange about us is that in our small, very small country, 10 million inhabitants, we have 6 different governments. And each of these governments has their own opinions and their own budget and their own strategy and their own targets, and they never come to an agreement. To give an idea, a couple of years ago, we spent 400 days waiting for a new government. We were without government. So, strange country. But if there's one thing where Belgians are good at, next to beer and chocolate, that is something they call the compromise. And a compromise is an agreement between parties. When you have two parties or two stakeholders who do not agree, they have each their different viewpoints, then the Belgians are very good in finding that compromise. The compromise is then that we take a part of the solution of the first party, we take a part of the solution of the second party, and we merge them together. Nobody is very happy, because they didn't take my solution, but nobody is unhappy. So that has a lot of advantages. The disadvantage of any compromise that you can think of is that, well, nobody is really happy, and you end up with not the best solution. You end up with a consolidation of everything. And the pivotal point of that is this example over there, that's our Belgian tax system. And it was my task as a test manager to manage a team of testers to test our tax system. Till a couple of years ago, taxes in Belgium were allocated via paper. So we had to fill in a lot of paper, and then taxes were calculated, you got a letter back, okay, this is how much you have to pay, or this is how much they will refund you. They changed that. Now we have an excellent application called Tax on Web, because you can fill in your taxes on the web, hence the name. And we had to test that. Due to the compromises in Belgium, for a normal person, you have more than 260 fields you need to fill in. Your income, the number of children that you have, where you live, what's your profession, how long have you been working there, how many houses do you have, what's the value of your house? A lot of fields to fill in. Suffice to say that for most people, that is way too complicated. They don't understand it. Even I tested the application for more than a year, I still don't understand how to correctly fill in this form. So we all use all kinds of tax consultants and auditors to assist us in filling in those forms, which is not very ideal. But my task as a tester and as a test manager on this application was also, can you please calculate, if we have to test this, how much time that would take? Can you make an assessment of the time, an estimation of the time, a budget of the time for testing this application? Because let's face it, taxes for your average country are very important. If you don't have taxes, you don't have income, you cannot spread the wealth. And that was difficult. Now, I would like to redo that exercise with you, but I'm going to simplify things a little bit. Because if I give you all these 260 fields to fill in, that's impossible. So let's do a small exercise. You are my group of testers, you're my test manager, and I want your advice. Suppose we have a very simple text calculation system with 3 input fields. We have your age, we have your civil status, and we have your place of residence. And contrary to normal testing, you know, the shift left test as early as possible, I will also already present you the interface. The interface looks like this. For civil status, you have 5 different statuses: single, married, living together, divorced, and widowed. For age, you have for persons younger than 18, persons older than 17, younger than 66, older than 65. Bear in mind, we had some excellent testers there. As you can see, we rounded the boundaries. No discussion about the boundaries. And where you live in Belgium, you live in the European Union, but not in Belgium, you live outside of the European Union. So question to you is, you're my testers, how many test cases would it take for you to test this very small application?
Wait a minute.
If they are dependent. Sorry. It depends if parameters are depends on each other or not. If they are dependent,
they are dependent.
So multiply.
Okay.
45.
How much?
5 multiply on 3 and then multiply on 3. 45.
45.
I guess.
Okay. Other opinions? Okay. Nobody? Okay. Well, 5 can be correct, 45 can be correct. It's very difficult to calculate. That makes my task as a test manager also so difficult, because I hear an excellent idea. We just multiply things. We have so many fields, so many parameters in each field, we multiply. That's true. Then you test combinations. But you don't test everything. You don't test boundaries. You don't test input fields. You don't put, or you don't test invalid values. These are all impossible. Let's make it a little bit more complex. We do the same exercise. We end up with age, with civil status, with residence, but we add some fields to it to make it a little bit more look and feel like the real world. We add your work. Have you worked, yes or no? We add the total of your savings account, your bank account. We add your wage, your yearly net wage. We add your ecological footprint, because, hey, Belgium is a green country. We add the amount of children that you have, because you get child allowance. We add how many properties, how many houses do you have, and what's their value. And we add how much you give every year to charity. That's a lot. Well, let's see. So the fields, we had 5 possible inputs for the civil status, 3 for age, you have 3 for place of residence. Occupation, you have 5, unemployed, full-time, part-time, independent, or retired. You have the amount of children, none, 1, 2, 3, 4, or more than 4. How much money you made last year, less than 20,000, 20, 30, 30, 40, 40, 50, and so on. You have your total value of removables, some values. You have your total savings account, and God, I wish I was in that last one. You have how much you gave to charity last year, and you have your ecological footprint. So please now tell me, how many test cases do you need? 10, okay. Great. You're hired right now in my team as a tester, but bear in mind, if you have any issues in production, it's at your cost. No, I'll give you a few tips. What I want you to see is that you have to test all combinations, just like the mister there said. Do they have an influence to each other? Yes, they have. Suppose they have. That we only test each combination once, and that you have no negative testing. So you're not going to test with negative inputs where the input fields are not working correctly. Any ideas besides 10? Yep.
You have drop downs there, so it's excluding inputting. I mean, negative testing. No?
If I tap through my drop downs and I go up or go down, or I enter some values, it auto-selects. Maybe it wrongly auto-selects.
So it has.
It's
other
possible.
sites, okay.
It's Belgium, everything is possible there. Well, that is the question I got as a tester.
Not the question. I asked not how many test cases do we need to test, but how much time do we have to test this form.
Well, that is what's been asked of me as a test manager. They don't ask me how many test cases you have. They ask me how much time do you need to test this. Because if I have to respond to the amount of test cases for my management, that delivers no value. But if I have to tell them how much days, how much weeks, how much months of testing would it take to test this. And my basis for that is the test cases. It's the ideal world. Most companies say we have to go live on that date and you have that much time. That is reality. But on this project it was, tell me how much time it would take for you to test it.
I don't have an answer, sorry.
Okay, no problem. Well, it's not a very difficult calculation. It's also, if you do this, it's just multiplying. It's multiplying each of the values of each of the fields. You end up with 36 million test cases. That's a lot. Well, I made some calculations, we did some trial and error thing, and we came out that writing a test case costs us 4 minutes. To create the preconditions, we worked in HP Quality Center, so creating a test case, put it in the right folder, preconditions, steps, filling all the mandatory fields, and executing a test case cost me 1 minute. That sums up to 5 minutes. That means if you multiply 36 million test cases, you end up with 378,000 man-days of testing. Or, in general, 2016 years of testing if you have one tester. My management was a little bit surprised. Because, as any good government, we change the rules regularly. Every year we change our tax rates. So, we have to do this every year. So every year we have to invest 2016 years. I got a response, Michael, that's a very nice calculation, but we don't have that much time. And I have a second bad news for you, Michael, as a test manager. We have forgot to tell you something. This is the system that we need to test, and we said no negative test cases and one test per combination. But have you thought about this? And I have some experience as a test manager, but I was flabbergasted. I had no idea how I could manage that. Well, there are some ideas that you can test, but how do you do that? How do you test all these combinations on all these systems, even with different .NET frameworks and Java installed? And how do you do that? And I started thinking, how can I? Well, I was looking for alternatives besides testing everything. One of the alternatives was outsourcing. Used a lot. You don't have the resources, or the resources are too expensive in your country, so you look elsewhere. And for us, that was India. So I contacted some Indian companies. And actually, this was the first time that an Indian company refused to work for me. I actually got a no from an Indian company. The response I got, and I still have it on mail, sir, you do not need an Indian company, you need a total of India to test this. Okay, so outsourcing out of the question. And besides that, to test such sensitive data, the rules, the tax rules of a company or of a country, you don't want to outsource that. You want to do that by local specialists. So outsourcing was off the table. Then my biggest manager, the government director, said, okay, I have an idea for you. I read this excellent book. We are going to do test automation. That solves everything. Okay, test automation. Well, I also read some books and have some experience in test automation, and test automation is key. If you go to an agile project, if you go to an iterative project, you want to automate as much on a low unit test level as possible to avoid regression, to make sure that the basic functionalities are tested. However, when I came into the picture, the developers had already tested. So the only thing we can automate was on a graphical user interface level. That consumes a lot of time, and which is very error prone. To give you an idea, there has been some research about test automation. The cost-benefit analysis of test automation is that you need to execute an automated test 6 times before it pays itself back. That's the investment you need, because you need to acquire the tool, you need to license the tool, you need to install the tool, you need to train the people, you need to create the test cases will fail. not due to the software, but due to the test cases you created. You need to update those test cases. If something fails, what is the reason? So a lot of effort in test automation. And we didn't have the time nor the resource to do that, so test automation was also not an option. Okay, option number 3, we're going to do cherry picking. What is cherry picking? Cherry picking is taking the best ideas out of an entire group. You have a whole bucket of cherries, and you just take the nicest ones. That's also what is called business testing or acceptance testing. We will not test everything, but we just ask, okay, what are now the most important tests? Well, Belgium, 10 million inhabitants, everybody has his own opinion. For me, it's the most important. I have a job, I have children, I have a house. That is my most important test case. But person X over there has no children, has no houses, so each combination is valid. You cannot do cherry picking there. If you work for Amazon, then it's logical. A customer will first register himself, buy 1 or 2 articles, pay for them. That's the happy flow. That's something you can cherry pick. In this case, that was not an option. So option number 4, we're going for risk-based testing. Sounds right. Okay, this slide is literally stolen from yesterday's presentation I gave. I also present something about risk-based testing there. And risk-based testing sounds fine. But how do you determine what is the most risky? Each combination is possible. And you can also determine that based upon the changes of the rules, I think you can safely say that people without an income are less likely to have a house and a decent savings account. So we will not test these at first. These are not that risky. But what if those fail? Well, then you get the blame as a test manager. So even risk-based testing was not an option. In fact, we tried, because I come from the structural school of testing, V-model, waterfall. So I said, okay, we try risk-based testing. So I created an Excel file with all the requirements that we have. And just to assess the first pages of the Excel file took us a couple of days. So it would have taken us more days or more time to just assess the risk of each test case than to execute it. So out of the question. What was then the option? And that is where the magic kicks in, the rabbit out of the hat. The option for me was something I never heard before, but I encountered it at the training at that time. The option for me was bug research. Bug research that came from an academical research, where they investigated for the major IT companies what is the origin, the causal analysis of the defects. So if you have defects in production or in testing, what is the reason behind those? And bug research shows us that there are 2 kinds of defects that are the majority of the defects. Those are the single mode defects and the double mode defects. Now what is a single and a double mode defect? If you think in code, a single mode defect is, suppose your code says, if you are younger than 18 years old, then you should not pay taxes. And the developer made a mistake and it says instead of younger, said older than. That is a single mode defect. You have one problem in your code, you have one defect. A double mode defect is a sequence of defects. If you are younger than 18, you don't pay taxes, well, that works well. If you have children, you get a tax reduction that also pays well, but the combination of the two, the double of the two, that causes the defect. That's a double mode defect. What the research shows is that more than 99% of all defects found worldwide, when they have to do with combinations, are due to either single or double mode defects. So that was our focus. If we can limit our test cases just to find those single and double mode defects, then we're clear. Okay, that was a plan. How can we do that? With pairwise testing. What is pairwise testing? Pairwise testing is a technique that comes from mathematics. Basic from mathematics there is the orthogonal array. Now, I'm not a math specialist, by far. I hated mathematics when I was in school. It's learning by heart, it's not applying in Belgium. So I had to do some research, I had to read a lot. And I found something that was easy. That is a binary orthogonal array. And what is a binary orthogonal array? Well, it's binary because for each situation that you have, you only have one option, yes or no, true or false, 1 or 0. For somebody who is semi-autistic like me, that's quite easy. That is something I understand. Now, how do you work with that? Well, the first step in binary arrays is that the number of test cases is your number of conditions plus 1. Okay, that's clear. I have 5 input fields, so I need 6 test cases. 5 conditions, 6 test cases. Ah, that's something, that's understandable. That's something even I, as a non-IT guy, can automate via scripting in Excel, for example. Okay. Second step, my first test case, all the conditions are true. Okay, fair enough. Also something I understand. Everything is true, positive testing. Great. The third test is my left diagonal, so starting from test case 2 on condition 1 to test case 6 on condition 5, these are all true. That's this diagonal, this one over here. Okay, also clear. And the final step, all the rest is untrue. Okay, I have my test cases. And as you can see, with this binary program, that you've tested each single condition as true and untrue. You've tested test case 1 and test case 3, condition 1 true and false. Condition 2 the same, 3, 4, and 5. So, with these 6 test cases, we have tested all single mode defects. We have assured right now that combination-wise, there are no more single mode defects. And what's even better with this orthogonal array, that we also tested each couple of combinations. Take, for example, this over here. Condition 1 and 2, we tested them both false, false and true and false, and true and true. And that is true for the combination of condition 1 and 3, 1 and 4, 1 and 5, 2 and 3. Every combination of each of the conditions has been tested as a couple. So we also avoided all the double mode defects. That means that if we execute all these test cases, we are certain that we don't have any mistakes against single line ifs and combined ifs. Now, we are almost certain. That does not mean that we are certain. If you want 100% certainty on finding all the defects against combinations, you need again to multiply. Then you need to have 2 to the power of 5, you need 32 test cases. Well, that's still valid in this case. But if I can tell my boss that instead of 100% certainty, we go for 99.8% certainty, and we get a reduction of 600% in time, he will be happy. I do the same amount or almost the same amount of certainty in 6 times less time. I like that a lot. Now the problem is that in real life, most interfaces are not binary. If you imagine an interface on a website, it's drop-down list, it's not only yes, no, or checkpoints. So then you come to the non-binary orthogonal arrays. And if you take a look on the internet, on Wikipedia, you find an excellent definition of that. I'm not going to try to even explain you what this is. I don't understand. If you want to read it, you can find it. No, I'm going to try to make things a little bit easier. Suppose we do the same exercise once again. We have the age, we have the civil status, the children, the properties, the work. We've come to that. Now, smart people, they have created complete catalogs, books, filled with orthogonal arrays, special arrays, matrices, that correspond to the values of such an array. And you can look them up for free. So in this case, you can determine what kind of orthogonal array do you need, and afterwards you look them up and fill them in with the right values. That is something I can tell my kids to do. So what kind of orthogonal array do we need in this case? Well, you first start with the attribute with the highest possibilities, which is the ecological score. 10 possibilities, so we need 10 possibilities to the power of 1. We need 8 possibilities twice, so this one. We need 7 possibilities 1. We need 6 possibilities twice. We need 5 possibilities twice. And we need 3 possibilities twice. And if I just enter this formula in Google, you will find that orthogonal table. It's that easy. Well, you don't have to use Google, by the way. You can find complete catalogs of that, or even a selector that selects things for you if you enter your requirements. What you see on the left-hand side here is the orthogonal array. The horizontal lines are the test cases. The vertical lines are the values that you need to fill in. That is what you get, mathematical. And then you're 99.8% certain that you find all the single and double mode defects. Great. So I explained this to my management and they said, they were lost. The moment I started about mathematics, they said, Michael, this is too difficult. I cannot explain it to my testers. I cannot explain it to higher management. Forget about it. Can you simplify this? I said, I tried. I did some lookup. And I found an excellent website and an excellent person, James Bach. James Bach is one of the gurus of testing. All credits to him for this part of the presentation, by the way. And on his website, he has a tool that's called All Pairs. And All Pairs uses the concepts of pairwise testing with a special flavor. And let's see how that works. And now it becomes difficult because I have to switch to tests. Okay. You can see this. Okay. If I open this up, I end up with an Excel file. I've prepared it. So you have all those input fields, civil status, age, residence, all of that. I have it in an Excel file. Okay. I just copy the entire table. So I select everything, copy. I go to Notepad, and I paste everything right there. That's it. Don't care about the syntax or how it looks. You just save it. So I do File. This will be difficult in Russian for me. Save as. I can tell to my wife tomorrow that I'm fluent in Russian. This is C. Okay, that I understand. Let's call this. Oops. Nah. Hey. Okay, I call this raw data. Okay. I've put it in an Excel file. I open up my command prompt. I have it already CD pairs. If I now type all pairs, which is the type, the name of the program, what was it? Raw.txt towards, let's call it testcase.txt. And let's hope it works. It works, great. If you now go to that location, you see that I have a notepad file called test case. Okay, I cannot read it, so I select everything, I copy it. I go to my Excel file once again, new tab, and I paste it. You will see that you have your test cases. You have your test cases with civil status, with age, with all the input fields. And if I go down, you see, you remember how many test cases we needed? 36 million something? Well, with all pairs, you end up with 97 test cases. That's great. I have a reduction from 36 million test cases to 97 test cases. Now, is this a silver bullet? No, certainly not. What you have is 97 test cases that you all should execute. The moment you miss one test case, you don't have the time for that, the entire model falls apart. What you see is, in the same Excel table, that you have pairings. How many times is this pair being tested? And you see, after the test cases, you have an overview of what pair has been tested. Here, we have tested the ecological score and the charity, so the combination of both of them, with value 1 and lower than 500. It appears one time in test case 1. And you have a complete overview, so if test cases fail, you can see what is the impact on each of the input fields. So for your developers, this is also worthwhile. My test case fails, but they do not have to investigate what's the reason. It's because of that pair of combinations. So they like it a lot. Let's go back. So this tool has saved me already a lot of time. Remember this calculation, 36 million test cases, 2016 man years of testing? Well, with this tool, 97 test cases means 1 day of testing. From 2016 years of testing to 1 man day of testing. For me, it's not magic, but it's almost magic. Does that mean that it solves all my problems? No. There are some problems with that. The first problem, and that's very easy to explain, is that 99.8% is not the same as 100%. And in most companies, that is just fine. I am very certain that for each company you work for, that you will never go live with any defect, right? All defects are closed before go live. Well, not in my world. Most of the times we have defects that we know of that slip into production. So maybe we can accept that, but most of the time not. The second thing is, and that is important, that there are different types of tests that you should do. This technique only focuses on tests that take as objective the combinations. We have not tested negatively, we have not tested the input, we have not tested the output, we have not tested the behavior of the application, we have not thought about usability, about performance, about security, about any of those non-functionals. This is just one technique for one objective. That saved me a lot of time, but is not complete. And third, you should take a look at your defect taxonomy. Your defect taxonomy is the defects that you found in your defect database, but also in your incident database. Go talk to the people from operations, from the help desk, and ask them what are the problems that customers are complaining about. If they have a lot of defects against combinations, then this is a good technique. But if out of your defect database it shows that nobody cares about these defects, well, this is not a technique that you should use. To summarize things, pairwise testing is not magic. Pairwise testing might look like the pot of gold at the end of the rainbow, and God, I wish I would flew to there in a couple of years. Unfortunately, no. But what can pairwise testing do for you? Pairwise testing can do two things. It can reduce your testing efforts dramatically for any combinatorial test. And for me that is important because in most of the environments I work for, combinations are the key. And secondly, it helps you to focus on different aspects. Those 36 million test cases, I cannot automate them. 97 test cases, I can automate. If I only have to execute 97 test cases, I can focus on all the things I have not tested with these combinations. On the input, on the negative, on exploring things. So this allows you to put your focus differently. Thank you.
Questions? Hi, thank you for your presentation. My name is Lena, I'm from Moscow, and I have a question about data that you use. So it's about people in Belgium, right? So why don't you use social statistics? So in Belgium live 70% people age more than 40 and so on in each step, and so you can test that cases that people use more recent. Why don't you use this method? Thank you.
Okay, thank you. That's an excellent question. I did not go in that much detail, but when I talked about cherry picking, that is what we did. So we take a look at statistics, geographical, social. We took a look at those, but for example, we have, I think it are 120 billionaires in Belgium. These are 0.005% of our population. Shouldn't we test their tax allowance? Because, okay, that you focus on the 70% which are in the normal range, and that works, that saves you maybe €1 million in taxes. But if you forget 1 billionaire, that costs you more. So it's a good idea, but with its downsides. Other questions?
Alexander is Soft. Thank you for a good presentation, and thanks for showing that defects are dependent on 2 or 1 field. And I believe that Microsoft was the original guy who implemented this idea. And they have also a tool called PICT. Have you used it?
Yes.
And what's the difference, and which of the tools do you find more useful for this?
Both tools are freeware, so that is something I like a lot. The advantage of the Microsoft tool is that it uses the orthogonal arrays to the strict sense. All pairs is an own algorithm developed by James Bach, so it uses a different categorization of things. It doesn't use orthogonal arrays because people are still doing research, and some complex problems cannot be solved in a Microsoft tool, where all pairs delivers an option. All pairs is less performant, so we'll end up with more test cases than the Microsoft tool, but Microsoft tool is more theoretical. But both are fine for me. Well, if I have to explain to my boss, well, we have normally 36 million test cases. If I use all pairs, I end up with 100. With Microsoft, with 80. He doesn't care which tool I will use. If I use any of those, he will be very happy. So try both of them.
Okay. And pairwise testing is also connected to domain testing and strong weak equivalence classes. Have you ever used this to reduce even more the number of test cases that might be used for testing?
No, no experience with that. I'm sorry.
Okay, thank you.
You're welcome.
I suppose we have time for final question.
I think
No?
everybody wants to go to lunch. Okay. Thank you very much.